Hey, you're now in magical place explained by you and E students. The analytic geometry place for everything you need and everything you don't, and it's it at your service. Hey there, today we're diving into some cool geometry stuff applies at their equation. Specifically, we are talking about the canonical or symmetry form of a line equation and how to find line that cuts away from both the x and x, right? And y-axis. Usually, when we're dealing with a line equation in canonical form, it looks like this, right? Where a and b are intercepted with the x and y axis respectively. But what if we want a line that's further away from both the x and y axis? This can get a bit tricky, right? Imagine waiting a line that's away from the x and y axis. The thing is, if the coordinate for a and b need to be possible real numbers for the line to cut the first quadrant, which limits just a bit, right? But hey, no worries. We got a solution, right? One way to solve this is by rewriting the equation to express y in terms of x, or the space, right? Getting the line equation or the slope-intercept form. This makes it easier today with the help to find the line that's fair from both the x and y axis. It started with the problem of the canonical equation and got out the extra stuff for now. First off, let's get familiar with its formula, and by that, I mean knowing where those points are. Yep, on the Cartesian plane. So, after figuring out a and b, just number we found a equals -4 and b equal 2, we're not going to stick to those letters. Nope, we'll give the new ones. I went with N and O because, well, why not? So, A is like N and B is like O. And here's a thing, A refers to the x coordinate and it doesn't mix with the other one. They're both independent, thus that's why we draw in the zero. The x coordinate is the x, and we add -4 to that. Same goes for O, is the y, and it's independent. So we add 0 to the x coordinate and 2 on the other side. Now, let's plot this so the Cartesian plane might not be perfectly straight, but it gets the point across. First, let's mark N on the x-axis and -4 and 0 on the y-axis. Starting point stuff, and for O, we plot its x-coordinate at 0 and its y-coordinate at 2. This gives us 2 points on the Cartesian plane, and now it's time to connect them. Draw and sign line user rule. Took my mind not turn off perfect. Finally, we figured out where this point on the Cartesian plane. Good, huh? Alright, let's get into making the formula. So, I'm imagining your data N and O have values of -4 and 2, right? Now we got to find the line controlling the x and y axis. Let me remind you on the values of A and B with y the way. Now we have these fancy names. We'll put these numbers into the denominator of both fractions as they were given to us. If the numbers negatives, guess what? The fraction goes -2, just like with that -4. Oh, hold on a sec. I usually forgot to add the equals 1 part, but I'm all out on space, so I had to erase it. Sorry. Anyway, we know his won't stay as I, knowing that the x coordinate or the x is negative. make it positive. To do that, we gotta flip the number to the other side where the number 1 is hanging out. So, going back to what we left off, the number 1 can be thought of a whole number. We can turn into a fraction. Since it's a whole number, let's write it as 4 over 4. Since it's next to the x coordinate as a fraction with a denominator of 4. Since in addition, not multiplication, we can combine the denomination to be the same, but the numerators are different because one has the x and you can just add them together. Setting that aside, their fraction won't stay the same. We'll move the denominator to the other side, converting it into a fraction. So, the denominator becomes the numerator. Add the number 1 to the denominator. Since we're doing the reverse of dividing, we turn into multiplication. Multiplying it out, we get 4 times 1 equals the number 2 has the denominator because they multiply and give 2. We can simply down the line, right? Alright, moving on to simplify things. The denominator of y will be multiplied over to the right side since it's divided in the same spot. When we multiply it, we don't change anything because it is the number 1. Y will move to the opposite side, becoming negative. On the left side, we'll put down absolutely 0. And that's it. We are the final result. So, in conclusion, the equation of the line that goes through the x and y axis is absolutely 0 is equal to x negative 2y plus 4. Right? And hey, thanks for hanging out here. Really. Until next time, cheers!